Proteus is a query finder as opposed to a query builder. In this instance, Proteus has been configured to target a database of Olympic medal winners for recent Olympic Games. To explore this database, I provide Proteus with some keywords, and in return, Proteus displays relevant queries. For instance, if I'm interested in the gold medals that Michael Phelps won, I could enter in his name and the words gold medals, and then I get some queries relevant to those keywords. I click on one, and I see the results. Michael Phelps won 18 gold medals in all. Now I'm interested in seeing this broken down by year. I add the word year, the set of relevant queries changes. I click on one, and I see that his gold medal winnings were distributed over 3 different years, as seen in this table. To look at the year 2008 in more detail, I might want to see for American swimmers in the year 2008, how many gold medals were won. The United States won 31 gold medals in swimming. If I want to see that broken down by athlete, I might add the keyword athlete, and then here I can see all of the gold medal winners in that year. The power of Proteus comes from the fact that I'm driving a complex process, which is the construction of well-formed and meaningful queries against a particular database. I'm driving that complex process by providing relatively simple input, just an unstructured collection of keywords. This process is familiar to people from using things like Google and Bing. For one more example going in a different direction, I want to see athletes over the age of 40. How many gold medals did they win? Who won gold medals after age of 40? This is interesting. And I see from the result table, there are more than I expected, actually. Maybe I'll add a keyword because I'm really interested just in those who won the most gold medals after the age of 40. And to lower the bar a bit, I will look at who won the most medals after 40, including silvers and bronzes. So I did before 40, there's after 40. So this gives an idea of the user experience for Proteus. We will now look at how Proteus is configured. What is the set of configuration data which allows it to support this particular database? This web page contains all of that data. In fact, it contains more than all of it. The create table statement at the top is not required by Proteus. It's just there for documentation purposes. You can see that the database in question here is pretty small. It's a single table. Below are a series of directives which define templates. The configuration information is a generative grammar, so it's a collection of interdependent templates which together are able to generate queries that are meaningful and well-formed for this particular database. The top-level templates are query templates, which generate complete queries. The next level down is phrase templates. These phrases are the things that the query templates are built from. And the phrase templates, in turn, are built from terminals. There are literal terminals and there are database terminals, termlit and termdb. The literal terminals are just words which are defined explicitly here in the grammar. The database terminals are defined using SQL queries, such as this. This highlighted SQL statement pulls the names of all the different athletes from the database. And what this directive does is it says that all of those names are terms, and the types of those terms is a type athlete. So when I enter in keywords, what Proteus is actually doing under the hood is it is on the fly mapping those keywords to terms as it is able. So when I entered in the name Michael Phelps, that matched the name of one of the athletes that was pulled from the database. So that was recognized as a term of type athlete. And similarly for all the other input I provide. So after the keywords are mapped to terms, then the terms are used to construct phrases. Each of these directives is a phrase template. Phrase templates generate fragments of meaning. And it does this in two ways at the same time. It generates a fragment of an English sentence, which will eventually be used to construct the English description of a query. It also, at the same time, generates a fragment of a SQL select statement, and that will eventually be used as part of a SQL query. And the important thing about the phrase templates is that it couples these two things together. So an English fragment, such as in tennis or in swimming, which would be generated by this template, is coupled to a SQL fragment, sport equals quote-unquote swimming, or sport equals tennis, etc. After the phrases have been generated, then Proteus, still on the fly, will attempt to combine those phrases to form queries, and these query templates are the rules which allow that to happen. There are only 3 query templates present in this grammar, but it is relatively easy to expand on that and to add more query templates and to expand the set of supported queries, since the number of queries grows combinatorially. By adding a relatively small number of templates, you are able to support a very, very large space of queries. That concludes this brief demonstration of Proteus. Thank you for watching.